So one more example. Let's find a fraction that's equivalent to 8/12. Now when I look at 8 and 12, I see right off the bat that these are both even numbers, which means that I can divide by 2. So we'll divide by 2 halves. 8 divided by 2 equals 4. 12 divided by 2 equals 6. So we get 4/6, and those are equivalent. Do you notice that the 4 and the 6 are both even numbers? Could we find another equivalent fraction by taking 4/6 and dividing it by 2 halves again? 4 divided by 2 equals 2. 6 divided by 2 equals 3. So we end up with 2/3. All right, that's interesting. So 2/3, 4/6, and 8/12 are all equivalent. Is there a way I could have went from 8/12 to 2/3 by just dividing one time? Well, the answer is yes, and it all depends on the factors. So let's take the time to list out our factors. The factors of 8 are 1 times 8, 2 times 4. 3 is not a factor. So 1, 2, 4, and 8. And then 12 has quite a few factors. 1 times 12, 2 times 6, 3 times 4, and that finishes it out. So 1, 2, 3, 4, 6, 12. All right, we already know that if we divide by 1, we will just end up with the same fraction. Notice that 2 is on the list. That's why we were able to divide by 2 up here, 2 halves. Do you see another number that's on both lists? If you spot 4, you are right. 4 is another common factor. So that means that we could take 8/12 and divide by 4/4, and we will be able to get an equivalent fraction. 8 divided by 4 equals 2. 12 divided by 4 equals 3. So we were able to find 2/3 as an equivalent fraction in one division step. So by choosing a different common factor, we were able to find a different equivalent fraction. Sometimes the numerator and denominator will have 2 common factors, like 8/12. They might even have more common factors. Sometimes the numerator and the denominator only have 1 common factor, and sometimes they don't have any common factors. See how we'll really be using factors to find equivalent fractions when we divide. Now that you've seen a few examples, you're ready to practice.